All right, so what we're going to look at today, we've been talking about inverses, how to calculate inverses of specific functions, right? We looked at the log function. We figured out how to take the derivative of logs because they're inverses of a known function, the exponential function. And we calculated, or we derived the standard forms for the derivatives of all the inverse trig functions. And we actually know using, like, we know how to do stuff. Like, will you guys tell me, how would you deal with something like this, just strategically? Like, what if you had some function that's maybe it's a function of y and not a function of x. Like, how about a sideways parabola or something? So say we have and let's say that we want to figure out what's the tangent to the curve when y equals 8 or something. What would you do? So if I were to graph this thing, it's going to end up being a sideways parabola. What could you do? So I'm specifying a y value. And let's just say that y value happens to coincide with that point right there. And that's the tangent that we want. Differentiate the function with respect to x, okay. Right, everybody see that? Now how would I do that if it's not solved for y? What kind of differentiation is that? Yeah, we could just implicitly differentiate with respect to x to solve for y prime, right? And then I would just need to know, when I calculate y prime, I would just need to know the values of x and y to plug in, right? Does that make sense? And that's going to give me a slope and a point. I only have a y value now. How could I calculate an x value? I could just substitute the y value, substitute it in and solve for x. Just evaluate this when y equals 8 and see what we get for x. Okay, I could do that. That'd be no big deal. Okay, that's good. What if, well, okay, sometimes it's very difficult to find an inverse, or maybe impossible, right? And there is sometimes there's an easier approach to doing this than trying to use like implicit differentiation or something like that. And sometimes we don't even have enough information to use implicit differentiation. Like some of the problems we're going to look at today, we have some specific tidbits of information, but we maybe don't even know what the function is, so we can't do a lot of manipulation with the function, but we just know the coordinates of some points. We just know some key pieces of information. And there's a relationship we can take advantage of here sometimes to get around what we think is not enough information. It turns out it actually is. So we're going to take advantage here of the definition of inverses. We know that the true definition of inverses is, this is the test for inverses. We would know that f and g are inverses if and only if. That's what the IFF means, remember, and that's like a two-sided arrow. It means that the sentence goes in both directions. So f and g are inverses if and only if f of g of x equals x. And think what that means. Inverses should cancel each other, right? So the f cancels the g and just leaves us with an x. And g of f of x equals x. So in both cases, if I take f of g or g of f, they will cancel, and I'm just left with what's inside, which is an x. Okay? So if we were to differentiate using the chain rule, like let's take this red statement and we're just going to differentiate that with the chain rule. We're great at that, right? We differentiate from the outside in. So the outer level, I've got f of hand. the derivative of f of hand is just f prime of hand, isn't it? Right? So I get the first link in the chain is f prime of hand times the next link would be, well, we'll look inside the function and take the derivative of what's inside. So we're going to get times g prime of x equals derivative of x with respect to x is 1, right? And then if we were to flip that around, it's the same situation, just we've just transposed the functions here with the blue statement. So the outer layer would be g prime of hand times f prime of x equals 1. We could solve either one of those. Typically, the red one is more useful to us because usually we're going to define f as the function and g as the inverse, usually. I mean, and really they're inverses of each other. But this just seems like this is the one that fits most of the time, although these both work. If I solve this for g prime of x, so our goal here is to know what is the derivative of the inverse function. Okay, that's what we're trying to find here. If g, we're starting off, f is our regular function we're working with, and we need to know the value of the derivative of our function's inverse, then this is in the box, this is our formula. The derivative of the inverse function is equal to 1 over f prime of g of x. Okay? This is, by the way, statistically, this is the most commonly missed part of both versions of the AP test. Thank you. All right. For you and for you. There you go. But really, I don't know why that is, because these questions, as you'll see, they're really not that hard. I think the notation is confusing sometimes, and they're a little tricky, but there's not a lot of calculus to do. It's not a huge issue, but I do want you guys to see this before you go to college. Really, I mean, if we were just cranking for an AP test, I'd probably just skip this because most people miss this stuff anyway, and there's not very much of it on the AP test. But that's really not what we're doing. So here's the trick. Here's the trick on this. What if we know, for example, we don't know what x or f of x are, but we know some ordered pairs. Let's say we know that if I input an x into my function f, the output is 3, and if I input a 2, the output is 5. So I've got these ordered pairs. Can you tell me two ordered pairs for the inverse function then? 3, 1. Yeah, 3, 1 and 5, 2, right? Okay, so we know we would have, because really all we're doing is flipping the x and the y. So what we're able to do here, if you make this double table, this, I swear to, this is it. This is what makes these problems really simple. If you just write this dumb double table where you put x, f of x in one row and then flip it around, because you know that for the inverse, we're flipping the x and the y. So what used to be f of x, the output now becomes the input for our inverse. And the output of our inverse corresponds to the input of our original function, right? So if we write these numbers on here, then this tells us this encapsulates both of those statements. Everybody see that? We just read the g backwards. Inputs are right, outputs are left, okay? And I'm telling you, that stupid little trick right there makes all this stuff a ton easier. Okay, let's try an example. And this is straight off AP stuff, right? So this is right off of an AP test. For which of the following decreasing functions f does f, the derivative of the inverse of f, evaluated at 10 equal negative 1/8? Well, first thing I would always recommend is replace the notation. If f is our function, replace f inverse with g. So it's easy to distinguish between the two, because f's and f inverses, especially if you have crappy writing like me, I mean, they start to look too similar, and it gets visually confusing. So change that into a g, okay? So we'll go down the line here, and we'll just take each of these one at a time and see which of these works, right? So we got to remember, let's try to just quickly memorize this. See if you can remember, see if you can write down for the function f, what is the derivative of its inverse g? G prime of x is equal to what? Try this real quick without looking, and then I'll let you look, and we'll just go through this about 3 times, and you'll have this memorized. So I'm going back. You want a quick look at it one more time? Here, stare at this for a second. There it is. G prime of x equals 1 over f prime of g of x, right? Okay. Now write it down without looking. Okay, when you're ready, look up and check it. Whoops. Tweak it if you need to a little bit. Okay. Try it again. Don't go to a different spot where you can't see it. Try it again. Check it. Okay. We got it? Everybody got it? All right. So let's go to this guy then. So we need to know what's our formula, right? We know, you guys tell me, what is g prime of x equals what? Okay, so let's test this out then, right? So we want to know what is g prime of 10, right? G prime of 10. Now on the first one, like if we apply this, g prime of 10 equals 1 over f prime of g of x. Well, what is f prime in A? What's f prime of x? -5, it's a constant, right? So what's this first one going to give me? If I apply this formula, I'm going to get g prime of 10 equals 1 over f prime of, who cares, right? Because f prime of anything is -5 on this one. Agreed? So my answer is -1/5. Gosh, that doesn't look like a -1/5. I don't know what that looks like. -1/5. And that's not what we want. We want -1/8, right? So this guy gets crossed out. Agreed? Okay. How about the next one? Let's go over, we need a little more room on the next one. Let's go there. Okay, what about this one? So, again, we know, whoops. We know that g prime of 10 should equal 1 over f prime of g of 10, right, in this case. Agreed? Okay. Yeah, come on, Gabe, step up your game, buddy. So now this time the derivative is going to be a function of x, isn't it, right? If we calculate f prime here, let's do that. If we calculate f prime, what are we getting? Okay, so we need to know what g of 10 is, right? Does that make sense? So how are we going to figure that out? Well, if we know that we're plugging 10 into the inverse, right? Where does that 10 go in our chart over here then? If 10 is the input for our inverse function, does it go in left column or right column? Right column, because it should be, because of that, right? That's the value of x we're plugging into our function. So we need a 10 there, and we need to figure out what goes there. Agreed? Okay, well, let's focus on this row for a second. Let's focus on the original function. So 10 is the input or the output of our function then? This is the output. That's the value of the function, isn't it? So what we've got to do here is we've got to go up and set our function equal to 10 and see what that yields, right? We got to figure out, we have to solve that equation. So I'm going to set my original function equal to 10 and solve. Well, that's going to give me the equation negative 2x cubed minus 2x plus 4 equals 0, right? I'm just trying to solve this equation so I could divide both sides by negative 2 and make things a little simpler. Everybody agree? And that gives me x cubed plus x minus 2 equals 0. Okay, now this is a dirty trick they play on the AP test. A lot of times they'll give you cubic functions like this where you can't use a quadratic formula, you can't factor it. But it always works out so that the answer is very simple. It's almost, I tell you what, 9 times out of 10, it's 1. Not kidding. That's the truth. I've done 1,000 of these problems, and and what do you know? It's 1. I mean, you can almost take it to the bank that it's going to be 1. It might be 0, it might be negative 1 or something, but it's going to be one of those three almost always. Not 0 wouldn't make sense, but 1 or negative 1 almost every time. So just by inspection here, and I know this doesn't feel very, very rigorous, but that's just kind of the way this is supposed to be a quick problem on the AP test. You don't have to prove anything, right? You're just trying to pick the correct answer so we can see that the simple real solution to this is 1. Everybody agree? Okay. So we can put a 1 there, and there's our ordered pair that we're interested in, okay? So the output of, when I input a 10, the output of my inverse function is 1. Okay, so then this is going to become g prime of 10 is 1 over f prime of g of 10, which is what? 1. Okay, well, there's our inverse function. If I plug a 1 into that, I'm going to get negative 6 times 1 squared is negative 6 minus 2 is negative 8. What do you know? We got it, didn't we? Right? That's equal to 1 over negative 8. And so that's our answer. Everybody see that? And if we went down the line, I mean, we could, maybe let's just look at, I think I got to calibrate this pen. It never goes where it's supposed to go anymore. If we look at some of these other ones, let's maybe just show real quick why this doesn't work. Okay, if I were to set this equal to, I think 1 probably works here. I bet it does, right? I think it does in this one. I'm just guessing, though, just the way these test writers' minds work. I'm sure that the 1 part works, but the derivative won't work. So that was a 1, that was a 10. If I set this equal to 10, that's going to work, isn't it? If I plug in 1, I'm going to get 10 equals 10, right? Everybody agree? So we still get the same ordered pair that we got last time, but our derivative is going to be different. F prime of x is negative 5x to the 4th minus 4, right? And so f prime of 1 is negative 9, right? And so we don't get what we need, do we? When we do when we do g prime, g prime of 10 is 1 over f prime of g of 10, which is just, which is just 1, right, from our table, right there, it's just 1. I get 1 over negative 9, negative 1/9, and it doesn't work, right? And it's pretty obvious, if you look at this last example, yeah, that's not going to work, is it? Right? I mean, you can already see, if I set this thing equal to 10, I'm not getting anything very nice out of that, right? I've got this exponential function in there. I'm going to get something that's not an integer answer, and so there's no way I'm getting negative 1/8. Does that make sense? How we could just logically Just disqualify that one. Okay. Give me 1 to 5. How are we doing? Okay. Oh, that's pretty good. That's pretty good. This stuff is a little, I mean, it kind of turns your mind around a little bit. It's a little strange. Let's try this guy then. How about this one? We've got a decreasing function g satisfies g of 4 equals 6 and g prime of 4 equals negative 2. Okay, this is the other thing. So they're using g as the original function, right? Which is okay. That's fine to do. If they're using g as the original function, we've got to restate our inverse formula for the derivative of the inverse. So now f becomes our inverse function, and f prime of x would equal what then? Yeah, 1 over g prime of f of x. Does that make sense? Okay, which is fine. We can do that. And so these should all, think of these all as being f's instead of g primes. Okay? So which one of those would have to be true? If, let's make our table. There. Okay, so this time they're telling us g of 4 equals 6. So I'm inputting 4 into g and I'm outputting 6. Agreed? So there's my ordered pair, right? Okay, so then I want to calculate g prime of what? F of x. You see what I'm getting at here? We're trying to do f prime of 6, right? Did I do that backward? No, I did it right. Well, I think I did do that backwards. No, I didn't. I'm fine. I'm fine. Right, f prime of 6, because we're inputting 6 into f and we're outputting 4, right? We want f prime of 6. So what does the inverse on the bottom need to be? Right? I said that backwards. Yeah, never mind. I was looking at the question wrong. Which one of these is right and why? Can you tell me? It's D, yeah. Everybody see that? See why it has to be D? It has to be D because if we're doing, so here's our formula, right? If we want to calculate f prime, this one makes no sense. We could disqualify that, right? Why would we be inputting a negative 2 into, into the inverse? Well, negative 2 never shows up in our ordered pair, right? It's got to be a 6. We want to input a 6 into the inverse function. This is actually our inverse row, isn't it? Right, remember that. It was backwards. That's what's confusing. That's what got me a second ago. F is the inverse and G is our original function this time, right? So this is the inverse row. We want to be inputting a 6. So it's got to be either A, we can just cross that guy out. It's either A, C, or D, right? And we know that F prime of 6 is 1 over G prime of 4, right? Well, G prime of 4 is negative 2, and so it has to be D, right? The part that I think messes people up on this is that 4, right? But remember, this time g is the original function, right? So it's backwards. That's why I just hate this one. I don't like this example because the f and the g are transposed. We're used to seeing g as the inverse. This time it's the regular one, and f is the inverse, right? So it's g prime at the output of the inverse. Well, the output of the inverse is 4. Everybody get that? Okay. And sometimes on these, you have to just sit there and stare at them for a while, and then eventually you just kind of the light goes on when you get on the homework assignment. Give me 1 to 5 on this guy. How are we doing? Okay. Okay. Okay, questions? No? Okay, let's try another one. I honestly think this is supposed to be a harder question, but I think this is an easier one in a way. So they're telling us g of x is the inverse of this function that they give us, and they want us to calculate g prime of 2. Okay? Well, we know that g prime of 2 is just 1 over f prime of g of 2, right? Okay? So we got to make our little table then. And what are we going to do? Where does the 2 go? In which column, left or right? The right, yeah, because 2 is the input to the inverse row, and this is our inverse row, right? It's the input to the inverse row, so we got a 2 there, and we just need to figure out what goes there, right? Well, if I read this in our regular function, 2 is the output, and we're seeking the input. So I'm just going to set this function equal to 2 and solve. All right? So if and what's it going to be? What's the answer? Just by inspection? Yeah, it's just 1, isn't it? Right? Again, just 1. Okay, so we get 1 as our output. There's our ordered pair. So g prime of 2 is 1 over f prime of g of 2. Well, g of 2 is 1. All I got to do now is just evaluate my derivative at 1, and that's the number that goes on the bottom. Everybody see that? So I never even had to know what the inverse function was. That's the beauty of this, right? All I need is, I just need to be able to, the only really challenging part of this is that, okay? I've just got to be able to figure out what both parts of that ordered pair are, okay? So what's that going to give me? If I differentiate this function, what's f prime? Yeah. Good. 3x squared plus 2. So f prime of 1 is just 5. So I end up with 1/5. Good? Okay, here's another classic one where they're going to give you some extraneous information. I'm going to try to throw you a curve. Give you a bunch of extraneous information, all right? So find f prime of 5 if they give you all this stuff up here. Okay, well, let's turn this stuff into some ordered pairs. How about, we'll color code this. So how about this guy right here? What does that become as an ordered pair? 2 goes which column? Or 5 goes in which column, sorry? Right column. 2 goes left, so there's an ordered pair. How about this guy? So that's telling me -3 right column, 5 left, -3 right column, 5 left column. Okay? So f prime of 5 is 1 over g prime of f of 5. So I've got two possibilities. If I take well, f of 5, how is that going to work with these last two statements? They're telling me what g prime is of some input values. Okay. In order for this one to work, in order for the brown one to work, what value am I plugging into the function? Well, 5, right? Okay. Does that match with one of my ordered pairs up here? I need the input. Does that make sense? Right? Does that match with one of these? That makes sense? Yeah. Okay. Does this one work? G prime of -3? See what I'm saying? G prime, is there any place down here where f of 5 is going to be a -3? Right? I need these are the potential values of f of 5. They're giving me g prime of a number. Does one of those make sense and one of those not make sense? I mean, what's the output of 5 if I plug in the original function, in the f, in the, this is the function row, this is the inverse row, right? What is f of 5? -3, right? So which one of these two is going to make sense as an input to our derivative then? The brown one or the green one? Green one does, doesn't it? Does that make sense? Right? Because in the green one, look, we're inputting a -3, which is the output of f of 5. Okay, so this first piece of information up here that they gave us, extraneous. We don't even need that one, right? We don't need this one. Those are the two that make sense right there. Everybody get that? Okay. So how could I color code that? So we're getting, let's see if I can write this. So f prime of f prime of 5, that's orange, equals 1 over g prime of f of 5. Whoops. Oh, go away. We'll call that's like our green number, right? There we go. Right? Because that's the output when I input a 5, and so that's the one that goes with that statement. So what's the answer? 1/6. Right? Everybody see that? You can see why they're tricky though. I mean, I get why people miss these ones because they're kind of tricky. On the assignment, when they give you problems like this, one thing that's a little bit confusing, it says find the derivative of the inverse of the given function at the specified point on the graph of the inverse function. Okay, so in other words, the input of this is in the table, it would look like this. they're saying input the 174 into the, it's going to be here, right? It's the actual input into the inverse row. Does that make sense? Like I tried one of these as a sample problem, and I just assumed this was just a point on the curve, so I was inputting, I'm sorry, you're inputting a 4 into the inverse function, right? That's what you want to input. So let's just do one of these. So like with this guy here, what's f prime? So 15x squared minus 18x. Okay, so then g prime, yeah, 174 is the input. That's what they're doing. It's the input of the inverse function, right? So g prime of 174 is 1 over f prime of what? Of g of 174, which is 4. See what I'm saying? So that's a 174, and that's a 4, right? Okay, anybody see that? Okay. All right. The assignment, I gave you a pretty short assignment on this.